Deep inside some of the most powerful laboratories on Earth, scientists are trying to do something that once seemed impossible: create a brand new element. Not discover it, but actually build it. At the far edge of the periodic table lies a region where atoms become so massive that they can barely hold themselves together. These are known as superheavy elements, atoms with enormous nuclei packed with protons. The problem is simple. Every proton carries a positive charge, and positive charges repel each other with tremendous force. The more protons you add to a nucleus, the more violently they try to push themselves apart. Eventually, the atom becomes so unstable that it falls apart almost instantly. Yet physicists believe there may be a mysterious region beyond this chaos, a place known as the island of stability. Here, certain combinations of protons and neutrons could create nuclei that survive longer than a fraction of a second, maybe even minutes or days. To search for this hidden region, scientists use enormous machines called particle accelerators. Inside these accelerators, heavy atoms are stripped down to their bare nuclei and fired at incredible speeds, sometimes reaching nearly the speed of light. When two nuclei collide under these extreme conditions, they may briefly fuse together. In a single instant of nuclear fusion, a completely new element can appear. One of the latest targets in this search is Ununennium, element 119. If confirmed, it would be the first element in a brand new row of the periodic table. To create it, scientists smash extremely heavy ions into target atoms with enormous kinetic energy. The collision must be perfect. Too slow, and the nuclei bounce apart. Too fast, and the new nucleus shatters instantly. But if everything aligns for just a fraction of a moment, the nuclear forces inside the atom can overpower the intense electromagnetic repulsion, and for a brief instant, a new element exists. Most of these superheavy atoms survive for less than a millisecond before decaying into lighter elements. But even that tiny lifespan is enough, because detectors surrounding the experiment can capture the unique decay signatures of the new atom. These signals are like fingerprints, proving the element briefly existed. Each discovery pushes scientists closer to the mysterious island of stability, a place where some superheavy elements might survive long enough to study their chemistry, or even reveal entirely new properties of matter. For now, elements like Ununennium exist only for the smallest fraction of time, created in violent collisions of atomic nuclei, and gone almost instantly. But in those brief moments, humanity proves something extraordinary: that enough energy, precision, and curiosity, we can briefly create matter that has never existed before in the universe.